All right then, it's that time of the week, Explorer, when we leave planet Earth just for a little bit and we search the solar system to seek out some science secrets. My name's Dan. Welcome to a brand new Fun Kids Science Weekly. Thank you so much for being there. Now this week, we will look at what really... it's a bit gross actually. We'll look at what really happens when you are snotty, you're sniffling, and you need to get it all out. What's happening in your sinuses?
It is trying to help you, and it may not feel like it, especially if you have a cold and your nose gets really sore, or you have allergies and kind of this nasal drip situation going on, but really it is your body trying to help you.
And in our ongoing quest to discover the best science of them all, it's a big question, we'll hear why studying spiders should come top.
Spiders, they are super smart, they have super skills. I study spiders from something, though, that you can't see. I study their DNA. I study the DNA that makes up a spider that lets it do what it does. Did you know that they can throw silken lassos? Did you know that they can use their silk on water as a rudder?
And you can join me on a tiny Japanese island to find one of the most elusive cats in the world. It's all in a brand new Fun Kids Science Weekly. And we'll start it off this week with our science in the news. And millions of people across North America looked at the skies a few days ago to see a total solar eclipse that plunged parts of the continent into complete darkness. Now, total solar eclipses happen once every year and a half, but often in very remote areas. So to be able to see this across North America was a hugely big deal. It stretched across North America, parts of Mexico and Canada, the United States. It happened when at just the right moment, the moon passes between the sun and the earth and it blocks the sunlight out. Now, if you're in the UK and you're a little bit jealous about the eclipse, don't worry, the next time you can see one there is in 2090. Just 66 years to wait then. Also, an extremely rare, blind, hairy mole has been spotted and photographed in the Australian Outback. The northern marsupial mole lives in one of the most remote parts of the nation. It's so rare that people in charge don't even know how many there are. It's about as big as your hand. It's got silky golden locks, no eyes, a short stumpy tail, and hands that look like flippers. Now, sightings of marsupial moles usually only happen a couple of times every decade. Every 10 years, only 2 or 3 is when we spot these things. It's amazing that we know that they're there, but we're not too sure how many there are. It just shows you how much of the world we know and how much is still undiscovered. And our final story this week, scientists say a collection of Viking combs is extraordinary and unique in the UK. The antler and bone finds were discovered in Ipswich, which is in Suffolk, during 40 excavations over the course of 20 years. Ian Riddler is a lead archaeologist on the project and joins us now. Ian, thank you for being there. Now, extraordinary and unique are special words to describe these finds. What makes the combs so incredible?
Well, several things really. I mean, generally in the sort of work that we do, we don't pick up Scandinavian combs from a site as a matter of course. It's quite a rare thing and it's not something you expect. I mean, a lot of archaeologists won't see one in the course of their entire career really. So to have 13 of them come out of Ipswich is, just fantastic for us. And we love it. They're wonderful things, really.
So what makes the combs themselves quite unique? So they've come here from Scandinavia. What are they made out of? What do we think they would have done?
They're made out of antler, and we suspect that some of them are red deer antler and some of them are reindeer antler. And that's something that's going to be investigated scientifically over the next year or so. People are actually going to take samples of them and work that out. Combs really show you at this period, they show you the movement of people. They demonstrate where people are going because Scandinavians came into Ipswich and were there for long enough to be able to work and discard these combs at some point. And it's quite early in the sequence of Scandinavians coming into England. These combs are somewhere around a period from about AD 870 through to about AD 925. So they're quite closely dated, because we can look at the Scandinavian typologies for them and work everything out from that. So we know quite a lot about them, but we just don't get them very often, so it's a real privilege to be able to work on them.
So if we're talking Scandinavians, Ian, do we mean Vikings here?
Well, we do. I mean, it's just that it's a word that gets used and probably misused a bit as well. So, but yes, I mean, these are Scandinavians, these are Vikings coming from the north. We think most likely the earliest of the combs are reindeer antler, and therefore really from the north. They're coming from northern Sweden or perhaps Norway, simply because that's as far south as reindeer go. They're very much an Arctic species, really. The later combs are red deer antler, and those we think we can pinpoint those to sites in southern Scandinavia, more or less the sort of Danish-German border. We think that's probably where they were being made.
So these were found during 40 excavations over the course of 20 years, which is a long time and quite a lot of digging. Where they were found, is there any similarities in the places where we found them?
Yeah, I mean, the sites vary, really. I mean, they're big sites at the Butter Market and Greyfriars Road near the river in Ipswich, and then a lot of small sites as well. And they're pretty well distributed between these sites, but they tend to concentrate up in the centre of the town, and there aren't many from the southern part of the town. So that gives you an image that maybe that was the important part, somewhere around the Butter Market, or at least it was the important part as far as the Vikings were concerned when they came there.
Now, I know that we don't want to push the idea of Vikings too hard with this, because as you said, it's often a term that we misuse. But what we know about these people from Scandinavia, Denmark, Norway, and a touch of Sweden, perhaps, what we know about them and their use of these combs, how much have we learned about what they would have been doing in the UK in the 800 AD and onwards?
Well, we know quite a lot from other sites, and it's partly a question that Ipswich wasn't a site that was ever really mentioned in these terms, but now we're able to kind of add it as a big dot on the map and say we know Vikings came to Ipswich at this time, and at a pretty early time as well. Research on all these things is ongoing, but these combs, I say, these combs don't turn up very often. I'm looking forward to finding the next one, but it won't be anytime soon. It's going to be a while, I think. So it's helping us an awful lot in trying to understand what happened to England at that period, because you have an area known as the Danelaw, which is the Scandinavian area, and then you have an area beyond that to the west and the south, which is the Anglo-Saxon area. And we can build a picture and start to develop images of how these two areas worked across the 9th century and the 10th century, and then again in the 11th century before the Normans arrive. And it is a fascinating picture. There's a sense of people moving about an awful lot. There's a sense of industries and crafts developing in some areas, but also of sort of economic recession in other areas too.
Yeah, amazing. Just so much. It's been brilliant to chat to you, Ian Riddler, lead archaeologist on this project. And remember, Vikings didn't have horns on their helmets. Ian, thank you for joining us. Amazing to travel through time with Ian Riddler, right? Who'd have thought that people way back, like thousands of years ago, would care so much about their hair and their beards, I guess, that they would use combs and make it out of the materials that they had around them. Brilliant to time travel with Ian. Let's travel through the wonders of science and your mind now. I'll answer some of your questions. Love this part of the show. Every week, if you have a science question that you want answered, can be about anything at all, something going on in the universe, something that you've heard and you're not quite sure if it can possibly be true, let me know. Normally as a voice note on the Free Fun Kids app, that's the best way, and I will sort it all out for you. First up this week is actually a message that was sent to me on the website, and it is anonymous. If you are going to send a question, I'd love you to leave your name so I can say hello. They want to know, how does a camera work? Well, the way cameras work has changed so much in over 100 years. The first bit of tech that was able to properly capture a picture was invented in 1816, and it was called the heliograph. Then in 1839, someone called Louis Daguerre created the daguerreotype, which is much closer to the cameras that we use today. Anyway, it works by letting a very small amount of light into it. The lens over the top focuses the light that's in the frame, the picture that you want to capture. Then the shutter opens and closes very quickly. The light rays focused by the lens then form an image in the camera. In the old days, that image would make it a mark on film, a very special type of material where the light would make this lasting mark on there that you were trying to take a picture of. Then you would take it into a dark room. You would use very special chemicals which would bring out originally the black and white, and then the colour which would lift it so it stayed on that film forever. Now in modern cameras, digital ones, and now really ones that you get on your phone, the light triggers electronic signals in the computer, which tell the camera what is happening so it can take a saved memory of it. Thank you so much, whoever sent that in. If it was you, brilliant question. That's how a camera works. Let's see what else we've got this week. This is from Cassidy, and it's getting quite snotty and sniffly. Thank you for sending this in, Cassidy.
Why do we blow our nose?
Cassidy, thank you so much for your question. Something so simple that I think we never actually wonder. Let's find out. Helping us discover why we blow our nose, Laurie Dove is with us from How Stuff Works. Laurie, thank you for being there. Do you remember the last time you blew your nose?
It was just a few moments ago, so I am well versed in remembering how to do this.
But why does it happen? What's going on, Laurie?
That's the question. And I love answering this because what's so fascinating about curious people is that they ask the questions that we should probably all be thinking about a little more often. So, blowing our noses, why? The big question here is what's happening inside of our nostrils. There's sort of this rich life going on in there, and it all works together for our health and well-being in what might seem like a mysterious way. It's actually quite simple. So the nostril membranes, which are usually a nice pink color like the gums or whatnot, they are healthy membranes. And if you happen to have a cold or allergies or something else going on, you'll notice that they may change color. And for children especially, who might be looking right up into the nostrils of someone quite taller than them, it is probably pretty evident what's going on in there. So it's important to take a closer look.
So the stuff that we blow out, the snot, what is it?
Well, the snot is this defense mechanism. So really what's happening is that when you have an invader, and think of it in kind of a Minecraft scenario, right? Where you have invaders like coming into your nostrils, there are certain lines of defense. So you have some very small hairs in there called cilia, and they all start waving together when a foreign contaminant comes in. And when they start waving together, we may interpret that as an itch or a tickle. And then suddenly we're compelled to help get that foreign contaminant out of our nostrils by blowing our noses. But along with that, we'll probably all notice that there is snot, by whatever word you want to call it. And that is really just the viscous liquid that our body produces to encapsulate that contaminant and help us expel it out.
Right. So when we see snot, I mean, it's a little bit gross, and so we must think, well, that can't be healthy. Why is my body doing that? But really, it's your body trying to almost glue and stick down anything that's trying to get in. You've got a nice ball that you can snot out.
Right? That's it. I mean, your body's helping. It's giving you something to work with. And so it's really in this partnership that's very nuanced and sophisticated between your body and your brain and everything that's happening there. And it is trying to help you. And it may not feel like it, especially if you have a cold and your nose gets really sore or you have allergies and kind of this nasal drip situation going on. But really, it is your body trying to help you. It's similar to when you might have a fever, and we are often quick to treat a fever because we know that that's some kind of sign of illness, but the fever is also working with our body. And the same is true of this snot, this mucus that we're able to expel.
So when we have a cold, why do we have loads more of it? Is it the body making more to try and catch more of the invaders? Is it more of the invaders actually trying to get in? Or why do we tend to be really snotty when we're ill?
Yeah, that's the question, because it is different from our normal circumstances. And so we particularly wonder why. And it is both of those things. So you really have a give and take there. So you have more of a contaminant, whether it is something that's viral, say from a cold, or it is a foreign object that has made it into the body, such as an allergen, or even something as benign as maybe a fleck of cracked pepper. So all of those things to various degrees will create a reaction in the nostrils, and then those are encapsulated. And so that's why you'll have maybe sometimes more mucus, more snot, and it might go on for a longer period of time. If you just have some pepper that you've sniffed up your nose, you may have a runny nose for a moment and blow that out, and it lasts just a short time. But if you're fighting a cold, it could go on for days.
Laurie Dove from How Stuff Works, thank you so much for joining us.
My pleasure. Thank you.
Brilliant questions today, all about shutters and snot. If you have anything you want answered next week, make sure you leave it as a voice note on the free Fun Kids app. Just click a button there. You can do it at funkidslive.com too. And let's get to this week's Dangerous Dan then. Recently, we've been searching around the universe, finding really weird, strange, often very deadly things in science. And we've been looking at some of the most rare creatures in the world. Let's head to a tiny Japanese island to find the Iriomote cat. It's a native to the island of Iriomote. It's a wild cat, one of the most rare and elusive on the planet. Only 100 are thought to be left in the wild. They are small, they are agile, they've got quite long hair but with a short tail, covered in short hairs there. It's got dark brown spots and some stripes stroking across its back. Now, some people think it's a rare type of small leopard. Others think it's a completely different type of cat. It's so rare that we know so little about it that we don't even know what it is. How amazing is that? Scientists argue about specifically what species it is. It's a brilliant hunter, we know that. Takes down small mammals, reptiles, even birds. It's a brilliant climber too. And even though it is so rare, we know that it's the top predator on Iriomote. It's incredibly important on keeping the balance of the ecosystem, making sure no other species can take over, letting others thrive. And it's really important in science that we've got these creatures that are almost the apex predators of their ecosystem, and they keep everything else in check. And this one looks mean, it looks wild, it's so smart, it's brilliant at hiding, fantastic at climbing, it's stunning, it strikes, and that is why the Iriomote cat goes straight onto our Dangerous Dan list. It's the Fun Kids Science Weekly this week in our Battle of the Sciences, when we try and discover which field should come first. We're looking at something, well, sometimes small, something a bit bigger. Often, they might make you a bit squeamish. Let's find out more. Trying to prove why their field should be first is Sarah Goodacre, Professor of Evolutionary Biology and Genetics at the University of Nottingham. It's all about arachnology. Sarah, thank you for joining us. You have 1 minute to tell us why arachnology is the best. It starts in 3, 2, 1, go!
So thank you so much for asking me. Archaeology, the study of spiders. Spiders, they are super smart, they have super skills. I study spiders from something, though, that you can't see. I study their DNA. I study the DNA that makes up a spider that lets it do what it does. Did you know that they can throw silken lassos? Did you know that they can use their silk on water as a rudder? Did you know that they can fly hundreds of meters up into the air and many, many kilometers just in a single day? Did you know that they fly past oceanic islands and some of the first creatures, brave pioneers that land there? Did you know that on your doorstep, in your garden, they'll be eating little insect pests that we don't really want? And did you know that they let someone like me have a blueprint, a template for making artificial spider silk that we might one day use in medicine or in engineering as new ways to cope with the world around us?
There we go. Just under the minute, Sarah. Thank you so much. And the answer to a lot of those is no, I did not know. But I'm very excited to find out. So let's just start right at the beginning. When a lot of people are a bit creeped out by spiders, why did you focus on it? Why have you dedicated so much of your life to trying to discover some secrets of this beast that we don't know?
Really good question. Why study spiders? Well, spiders are super smart. And the short answer really is that they've solved problems and I want to know how they did it. They've solved problems such as how to live underwater and produce silk that acts as a gill. It acts like a fish's gill, so they can breathe underwater. They have managed to fly up into the air using their silk as a sail. I want to know how they do this. I want to be able to copy it, so it might help us. But I also want to find out because you'd think this day and age we'd have a textbook that's told us everything there is to know about that little money spider that you might see on your doorstep or on your windowsill, and we don't. And I really think we should. So, for example, did you know that in your garden or in a local country park there's a candy stripe spider, and it comes in 3 different colours, yellow, pink and white, and no one knows why? Or did you know that the little spindly leg spider that you might see in your bathroom, if you tickle the web, it pirouettes, it spins, and nobody knows why. But some of them actually don't spin, and we don't know why they don't either. So all of these things, I'm trying to work out why, and what I know is when I get to the end of my career, there will be still so much more to discover. So I'd like to encourage all of you listeners, go and find out what there is that we don't yet know about spiders and other creatures and see how much fun you can have with it.
Well, you mentioned that, and this is normally a question I do right at the end, but you've prompted me here. When your career is over, what's the one thing that you really want to find out? Have you got some unanswered question that you just need to solve?
There is one. Yes, great question. I have one question I would like to solve. There's a little money spider that is 2 millimeters long and it lives under hedges in your garden or in your country park. Now, the males, they have 2 of their eyes up on a long stalk and the other 6 eyes sort of on their head. I want to know, can they see around corners? And I think we could work that out, but nobody's done it yet. And I'm hoping at some point to work out, can they see around corners? Because if they can, that might be why their eyes are there. If they can't, it can't be for that reason. So that'd be my one thing I hope to do.
That's brilliantly simplistic, right? I think many people might have anticipated some huge answer, but you want to know whether this one particular spider can get around corners. And that's the mark of science, isn't it? That we're so fascinated by one thing and we're just trying to prove that one thing.
Well, that's right. Now, the thing is, you see, the next level of sort of difficulty or complexity, if you like, is the fact that a spider's body plan, we know it's got legs, we know it's got a head, we know it's got a body. It's the same DNA patterns that govern, let's say, an ant. And an ant has got a middle as well as a head and an abdomen, and it's only got 6 legs. So all those complicated DNA instructions tell one little developing invertebrate to turn into a spider and another to turn into an ant, let's say. So all of these really, really complicated interactions end up with something that has, let's say, 6 eyes versus 8 eyes, or 6 legs versus 8 legs. And if you understand how all that came about, you can see then why something's got 2 of its eyes up on a stalk and the other 6 somewhere else. So actually, once I know what it does with those eyes, I can then start saying, right, what are the DNA instructions that tell it to do that? And that actually sometimes helps us, because it helps us understand what happens when things don't go quite right. What should we expect? Why do things not always go exactly the way that they should? And all of these things get poured into a big pot of scientific knowledge that helps scientists working on all sorts of other things solve their problems too.
Wow. So much in that. So many questions, so many answers. A brilliant case for arachnology. Professor Sarah Goodacre, thank you for joining us.
Very lovely to be with you.
What do you think then? Does the smart field of studying spiders go to the top of our battle of the sciences? Do you think that's the best science in the universe? We will have another genius letting us know why theirs should be the best really soon. Now, earlier on in the show, we had Laurie Dove coming on, answering Cassidy's question about why we blow our nose. And it reminded me of a brilliant podcast series that we've got with Benny and Mal. These are our microbe friends. They live in your body and they learn all about what's happening inside you, how things outside can affect what's going on inside too. And let's dive back into the exciting world of microbiology with Benny and Mal. Thanks to Cassidy's question, we're wondering why actually humans get colds and how we can prevent and stop getting ill.
Good Bugs, Bad Bugs, with support from the Society for General Microbiology.
Microbes get everywhere. They're on us, in us, and around us. If you've got a microscope, like me, you can see them for yourself. Look!
All right there.
That's Benny. He's a helpful sort of microbe. Lots of microbes are.
Not you again. Can't you leave us in peace?
And that's Mal. He's not very nice. A few microbes are horrible, and they're called germs.
Charming. I'm not all that keen on you either.
Hey, easy, Mal, mate. You're not doing yourself any favours there.
So, what's up, guys?
Thought we'd take a look at one of the most common collisions you humans have with germs. Catching a cold.
Yeah, it makes you humans all snotty and even more horrible than usual. Hang on. What are you doing with that tissue? Microbes don't have noses.
Just adding a bit of colour, that's all. Actually, it's a bit weird, isn't it, that humans talk about catching a cold when the last thing you want is a cold. If it was thrown at you, you'd want to drop it, not catch it.
Well, the germs that are responsible for most colds are so amazing that you humans don't even realise you're under attack.
Yeah, the culprits behind most common colds are the viruses. And check this out, there's 200 different types doing the rounds all the time, and half of them are caused by the rhinovirus.
Which gets its name because you catch it from rhinoceroses.
Yeah, that's clearly rubbish, Mal. He's just pulling your leg there. Rhino just means nose. You know, like the horn on a rhinoceros's nose. Now, you know me, Mal. I try to see the best in everyone, don't I? Viruses, I just can't like them. They're well weird.
I think they're incredible. So amazing. They can't exist on their own, so they basically break into the cells of other living things to survive.
Verging on the criminal. The virus has one aim, and that's to make more copies of itself, and it will do that by sticking to the host cell, breaking in and invading it.
And this is the yucky bit. It creates loads of copies of itself inside that cell, and then when the cell bursts open, the viruses get spread all around like a big germy bomb. Now that's a fireworks show I'd pay to see.
Unpleasant. So, how do you humans catch a cold? Well, we've had a look at some of the ways microbes get around, haven't we, Mal?
Yeah, you can pick up the germs from other people, or the air, or even water.
Or food, or surfaces, sometimes pets and insects, all sorts of ways.
So let's take a particularly stupid human who got sneezed on by a friend with a cold. The virus can only live for about a day outside of living cells, so it has to find something to attach to.
That's right, and if you get sneezed on, the viruses could get into your nose and throat in about 15 minutes. Here's a fun fact. If you get sneezed in your eye, the tear ducts carry the virus down to your throat. It's true.
Whee! Really? Sounds like great fun, like a waterfall.
Well, I wouldn't call it fun. Certainly not for the person whose friend has just very rudely sneezed in their face. Once the viruses have landed on the soft, wet, mucus-covered cells that line your nose and throat...
Pow! They start invading your cells, setting up their virus factories and exploding all over the place and spreading the new viruses around.
Which is about as disgusting as it gets. And they're pretty tough. You don't need many viruses to catch a cold.
Ha! And you don't even know it was being thrown at you for you to catch.
Luckily, your body can throw most colds off. It takes about 3 days for your immune system to start winning the fight, and in that time, the virus will be doing everything it can to spread itself around.
And talk about a bag of tricks. All that coughing and sneezing and wiping noses with fingers and picking noses. It all passes the virus around to other people. Remote controls, door handles, pens, you name it. Viruses can even sit on those surfaces and wait for a whole day for someone else to pick them up. I told you they were amazing.
But don't let Mal make you think that they're in charge. Humans can fight back. You want to stop the rhinovirus in its tracks? Just wash your hands. Use a tissue and throw it away. So simple. And try not to sneeze in people's faces. That's just bad manners.
Viruses love children because they have all sorts of grubby habits that help germs move about.
It's true. So children tend to get more colds.
Horrible, snotty oiks!
Hey, easy. No need to be rude. But what should cheer you up is that the older you get, the fewer colds you'll get. Your body begins to recognise them. Remember the antibodies we talked about before? And kill them off before they can start an attack. Oh, I think I might possibly be about to divide. How about you, Mal?
Yeah, definitely feeling dividey.
Dividing is something we bacteria can't help doing. Making copies of ourselves by splitting in two, basically. Here we go! Whoa. So, anyway, we better go. As you can see, microbes come in all sorts. Vast majority don't bother humans at all, and can even be helpful. I hope Mal and I have been, helpful microbes for you today.
You definitely have. Thanks, Benny and Mal. See you next time.
Follow the adventures of Benny and Mal on funkidslive.com/bugs. Good Bug, Bad Bug. Produced with support from the Society for General Microbiology.
And that is it for this week's Fun Kids Science Weekly. Thank you so much for listening. If you have a science question you want answered next week on the podcast, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. You've heard from Benny and Mal. We've got loads more brilliant podcasts that you can hear on Google, Apple, Spotify, wherever you get your shows. They're on the free Fun Kids app and at funkidslive.com too. And Fun Kids, we're our children's radio station from the UK. You can listen all over the country on our app, on the website, and if you've got a smart speaker, make sure you wake it up and ask it to play Fun Kids.